Get started. Wonderful. Okay, fantastic. Good afternoon, everyone. Welcome. Thank you so much for joining us today. My name is Hillary Goldstein. I'm the Public Programs Coordinator here at the New York Transit Museum. This virtual presentation is part of a series of online experiences we're hosting throughout the year. Our virtual public programs include conversations, presentations, workshops, and performances hosted by the Transit Museum. Many of these programs draw from our internal archives, collections, and exhibitions, but we also connect with other departments, even from within the MTA. Now, in case you haven't visited us before, the New York Transit Museum started as an exhibition in the 1976 bicentennial, and it was so popular it became a permanent museum in the 1980s. In pre-pandemic times, we would actually serve more than 500,000 visitors a year. We are located in a decommissioned IND subway station in downtown Brooklyn, and we also have a gallery and shop in Grand Central Terminal. Our programs have gone virtual during the pandemic, but even though the museum is now open, we're continuing to host online programs on a variety of topics and for a variety of ages. And the nice part is that this format really allows us to engage with museum and transit fans from all around the world. So thank you for being part of this today. Just before we get started on our program, I wanted to make a couple of notes. First, if you would like closed captioning for the discussion, you can click where it says live transcript or CC at the bottom of your screen and select show subtitles. If you don't see that option, please click the more button with 3 dots and you should see some more meeting setting options available. We are going to ask everyone to mute their microphones during the presentation, but again, please feel free to use the chat to comment and converse with one another. And time permitting, we can have a Q&A session at the end of the presentation. Okay, so now I would like to introduce our speakers and presenters for today. First, we have Peter Malvese, is a Vice President and Program Manager at AECOM with over 30 years of experience in the field of engineering, project management, and project controls. He has been working on the East Side Access Project in various roles for nearly 2 decades, having started in 2003. He is currently the Herald Program Manager and Acting Program Executive interfacing with Long Island Railroad, Amtrak, and MTA Construction and Development. He has assisted the implementation of construction, including tunneling, laying miles of tracks, power systems, communication systems, and more. We also have Michael Pujdak, who is Vice President and Project Executive at AECOM with 24 years of hands-on experience in construction management. He has been working on the East Side Access Project since 2002 in a variety of roles. He has overseen the open cut excavation project in Queens, tunnel excavation in Manhattan, and structural excavation projects under Grand Central Terminal. He is currently serving as the Program Management Consultant Project Executive, providing leadership, management, and policy guidance to consultant personnel. So I'm happy to hand off to you to lead us on this exploration of the East Side Access Project.
Nobody talking right now.
Mike, are you there?
Yep, there I am. Good afternoon. Today we're going to be discussing the East Side Access Project, which is a direct rail link for the Long Island Railroad through a network of new and existing tunnels to Grand Central Terminal in Midtown Manhattan. This is the largest infrastructure project currently underway in North America. Next, we're going to be just looking at a brief overview of the program with this video.
East Side Access is the MTA's largest capital project, with work spanning 3 boroughs and extending deep below Park Avenue in Manhattan. The project will deliver for LIRR customers a brand new terminal and concourse beneath Grand Central, nearly 8 city blocks long, 8 miles of tunneling, 40 miles of new tracks, and the modernization of Herald Interlocking, the busiest intersection of passenger train lines in North America. East Side Access will deliver faster commutes, fewer delays, greater reliability, and more options for passengers. Long Island Railroad riders will now have faster, direct access to the east side of Manhattan, easing overcrowding in and around Penn Station. The project is also expanding and strengthening our regional rail network, protecting us from future transportation crises. East Side Access is the first expansion of the Long Island Railroad in more than 100 years. When the railroad was first built, 37,000 people lived on Long Island. We now have 2.8 million residents. To support that growing population, all 11 lines of the Long Island Railroad will now connect to Grand Central Terminal as well as Penn Station, saving commuters to Manhattan's East Side up to 40 minutes of travel time per day, adding up to 10 days per year. With roughly half of Long Island commuters expected to go to Grand Central, there will be less crowding at Penn Station and on surrounding subway lines. East Side Access will create faster connections to JFK Airport, getting you from Grand Central to your terminal in roughly 40 minutes. And along with the construction of the third track and double track projects in Nassau and Suffolk counties, East Side Access will ensure we can meet the demands of Long Island's future population growth. Long Islanders will be able to take full advantage of the job growth around Grand Central Terminal in the wake of the East Midtown rezoning. Better reverse commuting options from New York City to Long Island will expand job opportunities for New York City residents and help Long Island businesses attract skilled workers, strengthening the island's economic health and future prosperity. Then there's the brand new Long Island Railroad concourse and terminal. Built directly below Grand Central Terminal and Park Avenue, the new 1,000-foot-long terminal can accommodate 8 trains at a time, enabling service for up to 24 trains during peak hours. Passengers will have easy access to Long Island Railroad through multiple entrances along Madison Avenue from 42nd Street to 48th, and many more within Grand Central itself. There will be cellular and Wi-Fi coverage throughout the terminal, and all digital signage will provide real-time information about train departures. Overall, this new destination includes 350,000 square feet of new space, including 25 retail storefronts and space for pop-up shops to meet the needs of daily commuters. A critical piece of our transportation system is Herald Interlocking. Built over 100 years ago, it is the busiest intersection of passenger train lines in North America. With nearly 800 trains passing through each day, the potential for congestion and delays is significant, impacting daily commuters. So East Side Access is modernizing and transforming Herald to eliminate that congestion and reduce delays. Over $1 billion is being invested to make sure that you have a faster and more reliable commute now and in the future. This ambitious and transformational project for Long Island Railroad and the region's future is slated to open at the end of 2022. East Side Access will make our regional transit system faster, more resilient, more connected, and more reliable for our future.
So once completed, East Side Access is going to be changing the transportation in the region for generations to come. And there's several benefits that the video discusses. Next slide, please. Several benefits that the video discusses, like faster commutes and less crowding. For a program of this magnitude, one can imagine that there's several key stakeholders, and I'd like to take this opportunity to thank our partners at the FTA and the FRA for their support. In addition, I'd like to thank our railroad partners, as there's a significant amount of coordination and planning that's required in order to build a mega project in and around active operational railroads. So who is MTA C&D? MTA C&D is actually a subsidiary of MTA, and they were a new subsidiary that does the capital planning and development for all the operating agencies. Currently, they have over $51 billion in their portfolio for planned work over the next 5 years. Let's take a look in a little more detail at the alignment of this project and what it'll be. So currently, you have the Long Island Railroad comes in from the east and goes through Herald Interlocking, where it connects with the East River tunnels going to Penn Station. And that's where all the Long Island Railroad service goes today. What this does is it takes on utilizing a tunnel that was built back in the 70s, the 63rd Street Tunnel. That existing tunnel will carry this new service. So we have constructed a network of new tunnels out in Herald Interlocking, as well as the reconfiguration of Herald Interlocking, which Pete Malvese will get into more details on. And then we've also done a network of new tunnels in Manhattan and reconfigured and connected to Grand Central Terminal. So the new service will come in from the east, from the Port Wash or mainline branches of the Long Island Railroad, go into Harold Interlocking through new network of tunnels across east, going west towards Manhattan through the 63rd Street Tunnel, turn south down under Grand Central Terminal. So over the next couple of slides here, Pete and I are going to be discussing the construction in Harold Interlocking and in Manhattan. So I'm going to turn it over to my colleague Pete Malvese at this time for him to go through Queens and Harold construction. Pete.
Yeah, thank you, Mike. Really happy to be here today with you guys to talk about East Side Access. And I'll be talking in depth about the work that we've been working on in Harold Interlocking in Queens. To give a little bit more depth of Harold Interlocking, this is where Amtrak trains meet up with the Long Island trains. So the Amtrak trains coming down from Boston through the New Haven line, meeting up with the Long Island trains coming from the Port Washington branch and the mainline tracks coming from Jamaica, moving through Harold Interlocking, which is really a big mixing bowl of track and switches. And they're making moves to get to the respective railroads to the East River tunnels to get down to Penn Station. As part of the project, we can move to the next slide. We're creating a new alignment to, bring the service into Grand Central. Harold Interlocking, as you guys heard, is the busiest rail corridor in North America. Over 750 train moves a day, utilized by 4 railroads, predominantly Amtrak and Long Island Railroad. But you have the New Jersey Transit trains coming from Penn Station that also lay up in Sunnyside Yard. And occasionally we have a short line freight railroad, New York Atlantic, that comes through the interlocking as well. All this goes back over 100 years to the Pennsylvania Railroad. So there's aging infrastructure, and that's been a big part of our project as well, is to rebuild all that aging infrastructure. Some of the major challenges are the competing regional outages that are happening. Over the years, there's just been a lot of work happening in the area at Penn Station, West Side Yard, East River Tunnel work, and even work on the east end of Long Island. They all compete for the same resources, and the outages and maintaining the operation is always key. So that's something that we've had to work through. And just the challenge of working in this active rail environment is really the biggest challenge that we face in being safe. Next slide, please. So the magnitude of the scope here is, we're putting in 95 new turnouts, putting in over 10 miles of track, and it's an expansion of the whole interlocking. We've put in 5 new railroad bridges, replaced the signal towers, 313 catenary poles. Most of those foundations are dug by hand, pretty much because of the logistics. We cannot get equipment out there in the active rail environment with enough time to do it. And then to erect some of the trusses that you see in this picture requires really careful planning and very limited outages. So the biggest window of time we get when no trains are running is Saturday morning and Sunday morning at 3:30 in the morning, where we literally get like 30 to 40 minutes. And we're trying to fit that kind of work in and do it safely. And also in terms of the expansion, we're putting in retaining walls, a new signaling system, new traction power systems. Going into the operational piece here, as I talked about this mixing bowl. So you can see here up at the top right, Amtrak coming from the New Haven line, Long Island comes in. So part of the issue here is that you have these mixing points, and these are points where the 2 railroads have to wait for each other, and it creates congestion. And that's some of the pieces that we've been trying to improve, as well as create the expansion of the tunnels for East Side Access. So as this moves down to the west, you have the moves that go into the 2 East River tunnels for the westbound side, and then you have 2 East River tunnels on the eastbound side that come out. The Jersey Transit and Amtrak trains also make moves via the loop tracks that come around into Sunnyside Yard. Move to the next slide. So now this is taking the same schematic, but over, laying all the work that we're doing here, and highlighting in blue is specifically the scope of work that's required for the East Side Access project. And the orange components were pieces that got negotiated and engineered into the alignment when this project was being cast to improve the capacity and the efficiency of the overall operation. So part of this was to remove some of those conflicts that exist when the Amtrak and the Long Island Railroad come together. But for the core East Side Access, we have a new midday storage yard up at the top there. We have the 3 board tunnels into the middle of Harold, with the approach structures coming up to the daylight there. We have a series of track switches, and then we also have the railroad bridges that support that expansion. We also put in railroad bridges for that expansion of what we call the westbound bypass on the top side. There's an eastbound reroute, which comes up in the middle for the Amtrak moves to remove some of those conflicts when they come out of these river tunnels there. And then we're also improving the moves on the loop tracks. So there's a replacement car washer for Amtrak, a rebuild of the loop interlocking, a creation of a new T interlocking as they make moves going around into Sunnyside Yard. And again, it's increasing capacity, speed, and just overall reliability. Next slide. So I just want to give you guys an overview, and this will get a little bit busy, but just to give you a typical day of the moves that will be happening once we open up. This is going to be like your AM moves from Grand Central. The Long Island Railroad will be making a move from Grand Central. You can just click through this as I talk to it. Into the midday storage yard. Also, Amtrak and Jersey Transit will be making moves into Sunnyside Yard. And then the Long Island Railroad will also have the ability to make moves from Penn Station into their midday storage yard. Amtrak will make moves here through this new eastbound reroute, removing those conflicts that we talked about to get up to the New Haven line. And then the Long Island Railroad will be making moves from Penn to Port Wash and to Jamaica. And then you can see from Grand Central, they'll be making moves from Port Wash and to Jamaica. And then we move to the westbound moves. So here it is, the Amtrak coming up into the expanded right of way, removing that conflict that exists, going to Penn. And then we have the Long Island making moves into Penn, Grand Central. And then we have the ability to use the bidirectional tunnel to also make moves into Grand Central and still make other moves into Penn. And then Long Island will still have their Hunters Point service, which is a diesel fleet coming into Long Island City. And then we have additional capacity to make further moves into Jamaica and Penn with these next animations. And then you can still see that the areas that aren't colored still gives you some flexibility to recover if there were some impacts. Moving on. So really the biggest challenge that we've had working in Harold is all of the detailed staging, planning, and coordination to respect that active railroad environment. Getting track time to do the work is very challenging, and to make sure that the railroad operation is never affected is very challenging. So our planning has to be long range and very deliberate. The implementation of all this work required 24 stages of signal cutovers to create the footprints to advance all the civil work. And any change that we made along the way to change that sequence required a host of software changes and hardware changes. So it's very challenging. On top of that, we have limited supporting railroad resources and outages because they compete on a regional stage with other projects happening in the New York zone. And the other challenge we had for a long time is that the operating railroad is unwilling to give us large windows of time to perform the work, because this is really one of the major hubs of traffic. And it's not as easy when you're doing like third track where they can shut down a branch and have bus service. You can't really do that here. So we've had to prove ourselves and get small windows of time to get like a 1-week outage and then work our way up to a 30-day outage. We currently have a 1-year outage underway to do an open cut excavation in the middle of Harold. But that's literally taken us years of building confidence with the railroads that we can do the work safely and succinctly. So going back at the start of our work here in Harold, this shows you what the interlocking looked like. Also pay attention to the landscape in the background with the buildings. So at this point in time, you can see just the city court building. When you move to the next slide and you look at 10 years later, you can see all of the work that we've done, but you can also see the expansion of Long Island City that's growing. But this just goes to show you just how challenging the work is. We have constant train movement. So every 5 minutes or so in the rush hours, you're going to see trains sometimes right on top of each other. So that's really the biggest issue that we have. All right, so I'm going to introduce a slide now showcasing work that we did in the summer of 2018 when we installed the Northeast Quadrant. This was work that we did under a 30-day outage. Again, it took us years of planning and coordination and getting approvals from the Long Island Railroad and Amtrak for them to write a service plan to cancel combo trains and allow us to put in approximately 9 switches removed 5 switches, and put in over 4,000 feet of track. On one side of this, we had the Long Island Railroad doing their direct force account, doing portions of track and switches. And on the other side, we had a third-party contractor performing track and switches. We had to orchestrate all of that. And then as we got done with all the track work, we transitioned that to Amtrak to do the overhead catenary wire. And we also had the Amtrak and Long Island Railroad signal crews participating to do a final cutover at the end. So this is just going to showcase that for you guys to see the work of that in 30 days. So before this point in time, we were only able to get up to a 2-week outage. So this was really our first major test to do something with 30 days. And we came out of this meeting it on schedule and with no incidents or issues. So we had to work very closely with both railroads and our contractors and have daily coordination meetings, around the clock to make sure that everything was achieved on schedule. So from that point in time, we came away with further extended track outages to the point that I mentioned. Right now, we have a 1-year outage to do a cut and cover short tunnel excavation in the middle of Harold that we're in the process of doing. So now I'm going to turn more towards the Queen side and the tunneling work that ties directly into Harold. That's where all these tunnels daylighted. But I'm going to walk you through from the beginning to how we got here now. Now in the Queens area, this was all soft ground tunneling, as opposed to the work that Mike will talk about in Manhattan. They have the hard rock tunneling, so totally different mining process. Next slide, please. So just to show from an isometric viewpoint here, this is in Long Island City. This is right by Queens Plaza and in the Sunnyside Yard area. So right off of Nolan Boulevard, we built the launch shaft here. This is what we call the Q-tip here. This is where we build a series of slurry wall panels and bracing and tiebacks to create the launch shaft. We dropped the TBMs in here once we had it fully excavated, and we did 4 tunnel boring drives using 2 machines. So once we drove out the 1 machine, we would have to capture the cutter head, bring it back, and relaunch it. On the slide, we show slide number 5, and Mike will talk about this, but this is the Manhattan launch shaft. So there's the tunnel bell mouth. We did an open cut excavation on the other side of Nolan Boulevard, where we dropped the TBMs down there, and then we drove them down through the 63rd Street tunnel into Manhattan. So in addition, I'm going to talk about the Nolan Boulevard crossing later on, where we actually tied those 2 launch shafts together, and that was a very challenging piece of mining. Move on to the next slide. So in 2003, this is really when the work first started. So going back, there was a freight rail yard here that was, the Long Island Railroads that we took over. We removed that yard. This has become the staging area for all of our work here to support the work, not only in Queens, but in Manhattan. So all the muck that came out of Manhattan actually came right out here into Queens, and nobody in Manhattan was the wiser. And Mike will talk a little bit more about it. But we also had to demolish a series of buildings to create the footprint here to develop this launch shaft. Next slide. This is just another viewpoint of the same area here in Queens as we started to lay out and get ready to set the slurry wall panels in. And now this is our actual excavation. With the slurry walls now built, we had to start looking at how we're going to move over into Sunnyside Yard. So when you see that train in the distance, we had to build slurry wall panels where those trains are. So we had to come up with a temporary alignment to shift those trains further into the picture here temporarily, so that we could go in, build the slurry wall panels, build a deck bridge, which would stay there, and then build the slurry panels and put the bridge in, then put the trains back in service, and then finish this whole excavation once we had it tied in. And then we'll see that on the next slide here. So now this is further expanded, so you can see here that we've been able to build that bridge that we're housing the trains, and now that's actually in Sunnyside Yard. So we've expanded this. And now we're, excavating out the launch shaft. It was mostly soil, but as we got down to the bottom, we actually encountered rock excavation, and we had to do some drilling and blasting of that and form out the rock excavation. Next slide. So this is down below, and we're in the middle of the rock excavation now, setting the stage for the final pieces of the launch shaft. But you can see the deck bridge that's carrying the Jersey Transit trains above, and the curved section at the top there is the Q-tip area. So while that's all going on, we were procuring the tunnel boring machines that I mentioned. So we had 2 machines coming here, and then also concurrently on the next slide, all of the tunnel sections were precast liner. So these were all fabricated at a plant upstate New York. And then those subsequently got delivered here to the Queens site. To support all this mining operation in Queens, it was really its whole operation. We had our own substation for this, and we had a slurry plant that just supported this operation. And then once the mining would start, the precast liners would all feed into that as well. All right, next slide. So now that we've, basically bottoming out the excavation, this is the final kind of launch shaft here. So you can see up at the top, we had the 3 revenue service tunnels at the top going into Harold, and the bottom is the yard lead, which basically goes around under Sunnyside Yard and Harold, follows the loop tracks, and comes back around to support the midday yard. Next slide. And now this is dropping the TBMs into place, and now we're actually in the mining mode. So we had down at the lower bottom, that's the yard lead drive that's going on, and concurrently, we're doing what we call Tunnel A. So 2 drives going on concurrently, working their way around. Move to the next slide. And then we had the final breakthrough of our first drive. This got actually bored into Sunnyside Yard. We captured the cutter head, then we bring it back to the launch shaft, and then we started the next drive. And this is just a picture of the finished tunnel, so you can see all the precast liner segments coming together. And now here's where we basically are today. So all of that's been covered over. And now we have the midday storage yard, which will serve the Long Island Railroad to the Grand Central service. But as I also mentioned, in the future, we'll have Long Island Railroad will have the ability to lay up trains from Penn Station here as well. It's a significant rail yard, 24 tracks, all modernized signaling with a lot of capacity. And what you also see here is a pedestrian bridge that we put in to serve the Long Island Railroad workers getting across the yard safely, coming out of the yard services building. Okay, so one of the biggest challenges that we had here, that we're done with the Queens mining, is connecting the Queens launch shaft to the Manhattan launch shaft. And it's 110 feet that goes under Nolan Boulevard, but we're in a very challenging area because you can see that we have the elevated subway, the N and Q lines, you have Nolan Boulevard there. And then below that, we have the I and D subway, which carries the E, M, and R lines. And now we have to come in with a short tunnel section that goes under all that. So we're not allowed to do any kind of open cut excavation. It would just be impossible because you would have to affect all of these lines here. We had to come up with a different tunneling method, and I'll show you in the next slide here. Here's a cross section of that same area where we're trying to get across, and you can see here the BMT columns and supports here, and the piles that come down, and they basically go right into the tunnel section that we have. So what we needed to do is to come up with an underpinning system to shore up and temporarily support those piers, okay, and the piles. And at the same time, to go across the 110 feet, we installed a frozen jack arch system where we installed a series of freeze pipes longitudinally going all the way across between the 2 launch shafts, and install the water and the brine to go through a network, freeze the water there, create a frozen arch and stabilize it, and then come in and do a concrete liner, and then do separate short excavations and temporary shotcreting all the way across. So it was a sequential excavation to go through that. These support piles are remaining in there. And once we got done with the entire tunnel going across, we were able to transfer the load back of the BMT columns onto the new tunnel structure once it has structural integrity. And then we pulled away the temporary support system that we had in place to do the jacking. I'm just going to show you a short animation on the sequential excavation that was done. So these are separate pilot drifts that went across. And then you have all these different liner sections that ultimately got pulled away once we got through. Then we put the waterproof membrane on, and then we put the final liner, and then we build the track bed, and we're done. This is the most expensive tunneling that we've done on the project. So a linear foot of this tunneling is approximately $880,000. So for the shortest section of tunneling, this was the most challenging piece that we had. Not to say that the other parts that Mike talked about are any less challenging. So with that, I'm going to turn this over to my colleague, Mike Pujdak, and he'll talk to you more about the Manhattan tunnel. Thank you.
Thanks, Pete. So we're going to start by talking about the existing 63rd Street tunnel. This tunnel segment here was under the East River, and this was a portion of the tunnel that we use in this new alignment to get the trains to Grand Central Terminal. Next slide. So this project, the 63rd Street tunnel, dates back to the 70s, and it was a bi-level tunnel with 2 tracks on the upper and 2 tracks on the lower level. The upper level got outfitted with the New York City Transit, and the F line currently runs service through there. But the lower level was always reserved for this project. So now we're into that portion of the job where we have retrofitted the tunnel. Next slide. So here's a picture of the early tunneling that was going on back in the 70s. And here's what it looks like today. It was retrofitted and modified. And basically we installed our tracking systems, our bench wall, did any leak repairs, closed up. There's areas between the crash wall that need to be closed up, and adding in all our systems elements. So this is about a 1.25 mile tunnel that has been rehabbed for the East Side Access Program. Next, I'm going to talk about the Manhattan tunneling and excavation. And I think the key here is to understand the complexity of the logistics. We had all this mining that we had done throughout the Manhattan alignment down towards Grand Central, under Grand Central to build out caverns. And all that material had to go back out through the existing 63rd Street tunnel. It actually went out to the shaft that Pete showed you on the one side, because we didn't have that Northern Boulevard connector yet. So we went through we went up and over Northern Boulevard with a conveyor belt and laid up all of our muck in the yard so that way it can be trucked off site. And that was one of the conditions of the EIS, was not to have a footprint for construction in Manhattan. So we moved 1.5 million yards of excavated material, and we're going to show you some complex building of structure that was all done without access in Manhattan, with the exception of some drop pipes that we installed for concrete access. And the other piece of it, just go back one, is that all the work that we did at the Grand Central Terminal location actually was supported through Metro North from work trains from the Bronx. So we built Manhattan tunnel project, East Side Access Project, from either access in Queens or access in the Bronx. Next slide. So we're going to focus on the right-hand corner here. This is a cross section through the project. You're looking at Park Avenue is in the central right side of the right-hand side of the page here. You can see that Grand Central is 2 stories, basically, where it tracks platform for Metro North. Got the upper level and the lower level, and we're deep. We're well below Park Avenue, about 150, 160 feet below Park Avenue, sort of right down the center there. And in our final configuration, we have a cavern. We have two caverns that are 3 stories high each, and it allowed for a platform on the upper level, platform on the lower level, and mezzanine, which is kind of a passenger flow. So if you come in at the upper or lower level, you would have to take an escalator or an elevator to this mezzanine, and then we'll get you out to the street. Next slide. So these caverns are 60-foot wide, 60-foot high, next click, and 1,143 foot tall, so long. So just to get a sense of the magnitude of how long this cavern is, it's several city blocks long, underground excavated space as two continuous spaces, and it rivals some of the iconic skyscrapers in terms of its length. In terms of Manhattan tunneling, we utilized two different TBMs, two hard rock tunnel TBMs. So we have different geology in Manhattan. We're in Manhattan schist. And as we excavated, we did rock support, either an array of bolts, shotcrete, or steel ribs, depending on the geology. We had an extensive amount of geotechnical borings that were taken to understand the geology and what we would find. And the ground behaved as we thought. The ground was in excellent condition. If you can see the center picture on the bottom, you usually don't bring your rock cut to a razor edge, but that's the kind of ground we were dealing with. It was 35,000 PSI rock. Overall, we did 8 tunnel drives with the 2 TBMs, recognizing that we had to muck all of this out through conveyors back to Queens. We did 6 miles of hard rock tunneling. Took 5 years to do. We had no receiving pit. It's a little different than what we had in Queens, where we had receiving pits. We were able to pick up the cutter head and bring it around via some sort of trucking transport, and then relaunch. We here had to pull back our machines. Next slide. So if we look at our caverns, once we did our tunnel drives, we basically did 4 tunnel drives through the station cavern. If you look on the bottom right-hand corner of this slide, you'll see that there's 4 trains, and those 4 trains are where the 4 tunnel drives were. And now we're going to start constructing our station caverns. So what we did was we were starting to carve out the upper piece of that station cavern by a combination of a road header machine and drill blast. And here you can see that we have excavation ongoing. This is we're bench excavation. This was a drill blast. Now, in this, we took 2,700 blasts under Grand Central. So there was a significant amount of coordination that we had to do with Metro North as we were blasting below their active train shed. So this was, again, years in the makings, and a lot of coordination with Metro North, a lot of instrumentation, and typically we would blast at night, somewhere, anywhere. If you can mute yourself, that'd be great. Thank you. Typically we would blast anywhere from 3 to 6 or 8 blasts most evenings between midnight and about 4 in the morning, trying to take advantage of the non-period of operation for Metro North. Next slide. This is just another picture of the excavation ongoing in the cavern. You can see in the center of the picture on the bottom that there's 2 workers down there with the mucking machine, the scoop, and you can get a sense of the scale here. All the way far in the distance, you can see the different tunnel bore holes, which we're now obviously creating one large cavern. Next slide. This is a picture of when we were done basically excavating. You can see we're mucking out the last of the last of the excavated material at the bottom of the cavern here. You can see the jagged walls, see the little dampness on the walls. So we're going to go through that next. So next step, while we're building the caverns and we're mining, we're doing this all simultaneously, right? So we got all the work going on, Harold, that Pete's talking about. We got all this mining going on. We got these station caverns being built. We have all these other adits and vent shafts that are being constructed. So this is a video that we're going to play now of one of the blasts from 55th Street. That was just another ongoing edit. So in that particular shot, we actually had mined from the top of the shaft, then we had mined out the cavern below, and then we were blasted out the rock plug that connected to. Next slide. So here you can see we've now poured a mud mat and we've sprayed shotcrete on the walls to get them smooth, to get prepped for our waterproofing material. Just another angle of the cavern. Next slide. Here you can see, I didn't talk about it, but we have a concrete arch that we already installed early on when we did the top heading. That's haunched into the rock, into a rock haunch. That way it's self-supported, and it made us protect any shift in movement of ground above us. And that's waterproofed above that. And then the yellow PVC membrane is the waterproofing membrane. Basically put a big umbrella around the cavern. It's a drained and open system. So the idea is that any water that percolates around the cavern arch or down the walls will be behind that waterproofing material, and then catch in our water collection and drainage system. And then in this case, it'll all pump out and drain out to 37th Street, which is our sump that gets pumped out from. Here we've got the waterproofing completed. You can see the water barrier is kind of trimmed out in the gray. That's given us little segments to deal with any areas that we may have to do any leak repairs. There's also grout hoses in those sections. But then the next thing we see in this picture is the lower walls were cast and constructed, and now we're going to be starting to build our structure. So we turned to kind of a hybrid method. We had cast in place walls, and basically a lot of the flat members, the beams and planking was precast pieces. So we had over 4,000 pieces for the two caverns together. This was done by Fort Miller, upstate New York, and erected by Tutorini. Next, you're going to see a video, which is basically showing you how you build a ship in a bottle here. You can see us laying up the precast beams and planking. You see the upper level being constructed in the rear of the cavern. Overall, we constructed the structure, the balance of the walls and beams in 1 year for both caverns. Significant amount of work ongoing. We worked 3 shifts a day for the last several years. This is what it looks like today. So since we finished out the structure, we've come in with all our MEP. We built out platforms, we built out track, architectural finishes have been installed. We're working on doing the terrazzo, grinding out and polishing the final terrazzo and testing. Escalators are installed. You can see one in the left side of the slide, and further back on the platform, you can see the elevator, the public elevator, and the glass enclosure there. In this section on the lower level, we actually have a double high space, because the mezzanine is in that like grayish blue glass, greenish blue glass. It's only half of the side of the mezzanine. So you have this double high space, no free of columns. And this is what the cavern looks like today, the station terminal. So all the tunnels that we had excavated also had to be waterproof and lined. And while we were doing all that work in the cavern, we were also coming through and setting up. Some tunnels had to have access because we were all feeding the job from Queens, while we took other ones out to build. So this is the waterproofing going in and reinforcement depending on the area of the rock zone. And then we cast the concrete. Next. Here's just a picture of what the crossover looks like going into 2 of the Ys heading into the station cavern. So next I'm going to talk about the Long Island Railroad concourse, and that is basically next slide is this is where we're connecting under iconic Grand Central. You know, one of the awesome things about this project is that, you know, there's thousands of people that come to Grand Central every day for commuting and for tourism. And, you know, we've been building this job for years without anybody knowing that we're building it directly below their feet. And it's going to be amazing when it opens. So you can see the next slide. One of the things is, where do you find the space to house a concourse that you need to support a project like this? And what we did was we took over the west side of the lower level of Grand Central. It was called Madison Yard for Metro North, and we actually built Metro North a new yard up in near Yankee Stadium in the Bronx, and that allowed them to vacate that space and allow us to start transitioning those 8 city blocks of space into our future concourse. This is a view of the concourse stretching from 42nd Street all the way up to 50th Street. So as I said, it was an old rail yard. So the first thing we needed to do was demo out the rail yard, and had crash walls and columns everywhere. And you can see some of the demolition work going on in this picture. Next, we started doing our subgrade utilities and our slab work. And here we're punching into the 45th Street cross passage, trying to start making a connection to that, a future connection to that cross passage. Here's another photo of the slab work going on and subgrade work going on in the concourse. Next, we get all the flat work done, and we start working on getting. Then we start getting our walls going and our MEP going. You can see we're starting to bring in our MEP, and we got our CMU walls going up. And start forming out the rooms. One of the unique challenges we had in here was that we actually had to build a structure within the structure for a lot of the space. We have our own roof and decking to separate ourselves from Metro North, and have all of our utilities above it, and have a gutter system and waterproof deck to make sure that we don't have leaks in the public corridors. And this is what it looks like today. It mirrors the grandest of what Grand Central looks like. This public corridor runs from 42nd up to 48, so it's 6 city blocks. And they'll have some digital media on the walls, and they'll have future retail behind the glass on the left and right. So now we've discussed our caverns construction and the terminal below. We've talked about our concourse. So next, we're just going to have a couple of slides to talk about the passenger escalator railways. So again, we had this forest of columns and space. So we needed to somehow figure out how to connect these large banks of escalators. So we had to do a major structural reframing. So we brought in some 65-foot long girders that basically knuckle to knuckle on rail cars. Had to take them off rollers, roll them in place. These are somewhere in the order of 4-foot deep beams with 4-foot flanges with no headroom, no overhead cranes. Had to use Hillman rollers, get them in place, jack them up, and then basically stick frame all the structural reframing around the columns, so that way we can do load transfers, take out the trains, the service of the trains above, the DOT viaducts. We had to get lane closures, jack the whole structure up, and cut the columns and get everything resupported, so that way we can clear the space just to find the space to build our escalators. Here you can see now the reframing is done of the train shed for this area, and we started our mechanical excavation. We had a requirement to do our excavation down to 17 feet below the footings before we can start our drill and blast. Here we are turning down the slope here. We're on a 30-degree incline, and we did our drill blast excavation. As we got further down the shaft, we were able to take larger rounds. And we started off with 4-foot blast, and then that opened up to 6, 8, and 10-foot as we got down. And at the very end of the picture of that little tunnel, there's like what you can see, a faint blue right past that machine. That's the tarp in the other side of the cavern. So we had made our connection. Obviously, there's a challenge working on this kind of a slope for men and machinery. But once we excavated it down and got our initial shotcrete in, next step was to do our waterproofing and lining. Once that was done, then we got into our MEP, architectural finishes, and installing our escalators. Overall, these are 150-foot long escalators, some of the largest in the country. And that's what they look like today. Now I'm going to turn it over to Pete Malvese to just bring us through a quick highlight of some of the systems work and close this out. Thank you.
Yeah, thank you, Mike. Yeah, so I'm going to take us through, kind of the last phase of the job is once we got all the heavy civil work done, we still had a major challenge ahead of us to do all the systems installation and integration to keep pace of this and to connect it into the active systems that we have in Harold Interlocking and for the Long Island, those systems go all the way back to Jamaica and also have connectivity into Penn Station to keep the proper communication. Next slide. So we have a multitude of systems here and, very complicated. So all this work is over $1 billion. We had 4 major contracts to do power systems, control systems, networks, ventilation, signaling, fire life safety, radios, and then system integration and security. So, very challenging to, bring all this home. Next slide, please. And then just to give you a sense of magnitude. So, 21 power substations. So, just one of these substations alone would be considered a major project. We have 21. There's substations for the traction power piece for the DC third rail, but then we also have facility power substations. We have 13 ventilation plants across the alignment, 65 communication rooms, 2,500 security devices, 7 pumping stations, 44 tunnel booster fans, over 550 million miles of cable, and 4 control rooms. So, quite an extensive array of systems elements. Next slide. So just to put it in perspective, in terms of the overall alignment, this just shows the traction power substations. So we have them starting in Queens near Harold Interlocking, working our way down through the existing 63rd Street tunnel that Mike talked about. And then we have several, throughout Manhattan, and then, 2 over at Grand Central themselves. Okay, next slide. So here is right near Sunnyside Yard. This is what we call the COA traction power substation. This was a prefabricated substation. This is the largest prefabricated substation that was built in North America. This came to us several years ago, and we've connected it now into the Long Island Railroad in Harold Interlocking, as well as for the alignment going to Grand Central. And this shows the array of facility power substations. So we have 15 facility power substations across the entire alignment here, which support all the other systems that we have between the tunnel ventilations and all the other system pieces. This is just a snapshot of one of the bulk power substations that we have over at Grand Central. All these are fed from Con Edison. And here we're stepping down the voltage to support facility power and traction power. And then on the tunnel ventilation systems, we have, as I mentioned, 13 vent plants scattered around through Manhattan and Queens, sized at 300 horsepower. Some of them are in a horizontal configuration and some of them in a vertical configuration. We also have a extensive signaling system. So this just shows you some of our signaling rooms where we have the racks and relays here that support the entire system. So this has connections at Grand Central, but as I also mentioned, it ties directly into Harold, and then also has connections into Penn Station Control Center and to Jamaica. Okay, here's a picture of what we call the TOC, or the Train Operations Center. This is essentially the theater where they will make the moves and dispatch the trains. And this is all coordinated with the Long Island Power Bus. And here is the other, the Terminal Management Center that controls all the different facility systems between ventilation, all the different building management systems, the elevators, escalators, smoke exhaust, and fire life safety. Okay, and that's really the wrap up. So just to show you, this picture here is not a rendering. This is actually a rail train in Grand Central that was run in. We're currently running test trains in. The Long Island Railroad is going through their physical characteristics training, and we're starting to run test trains in. So, you know, we are working to deliver this in this calendar year and make the revenue service happen. And it's been, you know, a long road for me and Mike, but we've had the pleasure of seeing this from literally just, you know, pencil to paper as a concept and being able to see it all the way through this final phase. Thank you.
Great. Thank you so much, Mike and Pete, for sharing your work and giving us an overview of such a complex project. The photos and videos were really incredible to see and give us a sense of the magnitude of the project. So thank you so much for being here. We just have a couple of minutes left, and I pulled a couple of questions from the chat. And we can just go through a couple of those before we conclude today, for those of you that would like to stay on. So one question from the chat is, how much of the work is dependent on technologies that did not exist at the inception of the project? For example, massive computer horsepower. And how much technology whose maturity was not where it is today? For example, machine learning or AI. So I don't know, Peter, Mike, if you want to field that technology question.
Paige, do we have an answer for that?
Hi, everybody. My name is Paige Biancamano. I'm the Director of Communications and Community Outreach for Eastside Access. The one thing that I can speak to specifically about technology is that Eastside Access was originally planned and the EIS was signed back in the early 2000s. So we continuously update, we're continuously updating the infrastructure that we have built for the project to support what a 21st century passenger commuter wants in their service. So things like Wi-Fi, digital, cellular, those are all things that weren't necessarily planned for with the original planning of Eastside Access, but all things we have taken into consideration as we deliver this service at the end of this year. I can't speak to the technology for the construction itself, though, and I would defer to Mike or Pete. But if there's something specific you want, I can definitely put my email in the chat, and you can send me a direct question as well through my email.
Great, thank you so much. I also have a question here about the timing. So the question is, has the deadline been pushed back or is it still 2022?
Currently, the opening date is by the end of this year, 2022.
Great. Okay, so we are just coming up on 2 o'clock. So I just want to thank all of you for being here with us today. Thank you again so much, Mike, Pete, and Paige, for joining us. We have another virtual program next week that I invite you all to sign up for and attend. It's on April 20th at 6 p.m. Thomas Abdallah, the Assistant VP and Chief Environmental Engineer for the MTA Construction and Development Agency, will take us through some of the MTA's past, current, and future efforts to achieve environmental sustainability. So if you'd like to check that program out, you can find more information online. And we hope to see you at the museum in downtown Brooklyn. For those of you that are local, we're open Friday through Sunday, 11 a.m. to 4 p.m. So thank you all once again, and we will see you soon.